So we are talking about reflections today in 3-1, and this idea of something being a rigid motion. A rigid motion is a transformation. When something goes for a transformation, what does that mean it did? Changed, right? So something's gonna be different, and that preserves the lengths and angle measures. So like if I had this, see how I have this star right here. If all of a sudden this star is now here, would that be considered a rigid motion? Yes, because what did I do when I made this new star? I copied and so everything is identical. Does that make sense? Would this be considered a rigid motion? Because what did I do? Change lengths and, well, maybe I didn't change the angles, but like that. Now would that be the same? Would that be a rigid motion? Because in a rigid motion, what did we say? All the lengths and angles stay the same. This right here, no matter what, is always called the pre-image. So this is called the pre-image. What you start with is called the pre-image. What you end up with is called your image. Pre kind of means before, so before image. The image is the after one. Does that make sense so far, yes or no? Rigid motion is a transformation that preserves lengths and angle measures. Is a transformation that preserves lengths and angle measures. So that is called a rigid motion. All right, so one of the rigid motions that we have is going to be known as a reflection. Okay, and a reflection, right? If you guys ever written in a yearbook? Anyone ever written in a yearbook? The kid that used to drive me nuts would be like, I'm the clown that came to town to sign your yearbook upside down. You ever seen like any of that? Yes. And the kid, like there's stuff, right? You guys never signed a yearbook before? Oh, I'm sure they do. Like that was the one that we could talk about in class. Right. But here's the thing that we're talking about that I want to discuss with reflections. Have you ever signed a yearbook? You said something really nice. You did it in Sharpie, and then you closed the book. Oh, why? Why did we make that noise? What happens when we close the book and the Sharpie's not dry? What happens? All of it gets transferred to the other, especially if it's that glossy paper. You know what I'm talking about? And it's still wet. It's not dried. You have to. That's why some people will sit there and like leave it open. Like, hey, here it is. Don't close it yet because it's still wet. You guys all know what I'm talking about, yes? That's the idea of a reflection. A reflection is, now when they wrote, like if I wrote the word here, like if I wrote hi here, when I close the book, is it going to say hi over here? No. What's it going to be? It would be I and then H, right? Because the distance from here to here of the I would be the same as the distance from here to here is the I. And then the distance from here to here from the H, boys, will be the same as the distance from here to here. Does that make sense? So what happens when I have a point on here? And we'll call it this point right here. What is that point? First off, let's review that. That is something. It is -2, 3. What would be the ordered pair if I reflected it over the y-axis? Does everybody understand this is the y-axis, what I just labeled in red? What would be if I reflected it over this? Because what do we know? It's going to be the same distance from the y-axis, just this way. Just reflected or mirrored, yes? So what is my ordered pair now going to be? 2, 3. Let's talk about it. What stayed the same, though? Because what are they both? They're still the same distance up. So notice the y didn't change. And the x just changed from a -2 to a. Does that make sense, yes or no? Nope. Yeah, it could be any. So like I could give you this and say the order pair is over here. Right? Then you would be closing the book and now it would be transferring to this side, right? So I would go, okay, how far is this away from here? Well, it's 3 away, right? So I'd go 3 away this way. So my order pair here was +3, 4. What would be my order pair for this one? -3, 4. Does that make sense?
Can a reflection happen in the same, whatever that is, a quadrant? So like if you...
Yes. So like what if that's a good question. So I don't have to only reflect over the x-axis. Like what if I wanted to reflect over x equals 2? Well, x equals 2 is this line right here. That is that line here. I'll even do it in a different color to help us. Boys, this is called the x equals 2. So if I asked you to reflect it over that, right? And my ordered pair is here. What is that ordered pair? -2, 1, 2, 3, 4, 5, right? Well, this time I'm not going back to here. I'm going all the way to there, right? So how far is that? Well, it would be 1, 2, 3, 4, right? So what does that mean? I'd have to go over here. 1, 2, 3, 4. I'd have to go forward this direction. So what would be my new order pair would be 1, 2, 3, 4, 5, 6, 5. Because it's equal. What do I know about a reflection? The distance here is the same distance from here to there. Does that make sense? Questions on this? Okay, what if I had I asked you to reflect this one over the x-axis? Well, now what am I asking you? This is now the x-axis, right? So I'm going to reflect it over that. So that means I'm going to go this direction. Does that make sense? How far was it from the x-axis? 1, 2. So how far am I going to go up from it? 1, 2. What is this new? This order pair was 3, -2, right? What is this new order pair? Still 3, but now +2. Don't get distracted by me. I know it's hard. It's just my voice.
I'm not trying to figure out the
You got it.
I'm just gonna skip them.
You can come back to it. All right. So what do we know about reflection? Reflection, if I had a line like this, what if I had a line like that? And I wanted to reflect this point. How could I reflect that point? It's a good thought. We're actually going to, that's a really good thought. We're going to do that next. Yes. That's a really good point. But well, what if I was constructing it? Like what happened when I was reflecting it? What did I make sure, like when I did this, what kind of line, what was I making sure that this reflection was? Perpendicular to whatever line I was reflecting over? Are you following me? So what would I draw? I would want to draw a line from this point straight down to this line. And what would I want to make sure that these two intersected, this line and the other line? What do they need to intersect at? If they're perpendicular, what kind of intersection are they going to intersect at? 90 degrees. You follow me? And whatever my distance is here, I'm going to continue that parallel line and go here and go that same distance, and boom, that would be my reflection over this line. Yes. That's what we would do to do the reflection. In order to do the reflection, you're going to mirror it over the other side of that line. Like, look, Hunter, when we reflected over this, the point was here. We reflected it 90 degrees the other direction, right? So if I have a line at an angle, my point's here, I've got to see that this is my 90-degree angle, and then this would be my reflection. And this distance would be the same distance here, which would make this line going through, Brody, what did you call this point right here? That would have to be the midpoint of these two. Yes? Something new. If this is called A, and that is my pre-image. My pre-image, is that my OG or my one that's moved? Then this is what we call a prime. That is something new for you today. This is a new symbol for you. This is called A, and that word means, or the symbol means prime. What does it tell you if I'm doing A primed? That's the transformation one. Yep, that's the one that was transformed. So let's talk through this construction. What if I had a shape and I wanted to reflect it over that line? What would I do with this? We'll call this A, call this B, we'll call this C. So what would I do to the first one? What would I do to A? What would I say if it was a point? What would I have to do? I gotta connect a line from A to the line I'm trying to reflect over. And what kind of line does this have to be compared to this? I'll draw this in red. What it has to be perpendicular. Do we know how to construct something that's perpendicular to the other line? Yes, we should. Do you follow me? Yes or no? Then, do we know how to continue that line? And then I'm going to make it a little bit longer. And what am I going to do with my compass here? Because don't I need to make sure the distance from here to, crap. Don't I need to make sure the distance from here to here? Come on. Why is this thing being all funky? Why won't you let me grab it? There it is. How do I make sure the distance from A to the line is the same as the distance from this line to my other one? I take my compass right here. Yeah, makes sense? Oops. Come on. And there, now this is where my reflected A point is. Which, what am I going to call it? A what? A prime. Does that make sense? Yep. So right here, I'm going to take this and This thing's not doing what I want to. Right there, if I connect that, do you see that that spacing is now that same exact length, right? So then if I come down here and I put this on the line and then I do my arc, that's going to be that same distance. Does that make sense? So again, what are we going to do with B? I'm going to make sure that I draw a line that's what to the line, to the red line. And then I'm going to continue that line so it goes past this. Measure my length because this length right here has to be the same as this one. I'm going to draw that point wherever it may be. It's probably somewhere back here. Right now, I'm just giving you a sketch, the idea of what this would, and this would be B prime. Same with C. Draw this, make sure it's perpendicular. Draw it, make sure it's perpendicular over here. Make sure that this length is the same length as this one. Boom. And then connect. And now I've got my reflected triangle. Does the idea or concept of that make sense? Yes or no? All right, try these then. So this is going to be shape J, F, G, and H. So it looks like this. This connects here, this connects there, that connects there, and that connects. I want you to reflect that over the x-axis first. Reflect that over the x-axis. Hopefully it's not taking you that long. Remember, you won't need to do much for this one. Since I'm reflecting over the x-axis, what do I know about all vertical and all horizontal lines? What do they intersect at? What do all vertical and all horizontal lines intersect at? What kind of degrees? 90-degree angles. So does that mean I can just, when I want to flip this over, don't I just go, hey, that was up 1, 2, 3 for F, so I'm just going to go down 1, 2, 3, boom, there's F prime. Are you following me? What happens when I try to flip J over the line? It stays right on the line, doesn't it? So this would also be not just J, but J prime. Where is G? What is the order pair for G? What is it, the original? 2 comma what? 4. What is my new one going to be? No. 2, -4. So 1, 2, -4. And that's going to be my G prime. And then instead of 1, 2, 3, 4, 4, 2, I'm going to go 4, -2. And there's my H prime. And there is my reflection of that shape. Do you see how this distance from here to here, those are the same? From here to here, that's the same. Do you follow, yes or no? All right, flip it over the x-axis or the y-axis then. Same question. Now I want you practicing flipping it over the other axis. So now you're flipping it over this one. All right. What point's going to stay the same? F is going to stay the same. So that's going to also be F prime. Where is J going to go? The ordered pair is -2, 0. So what's it going to turn to? 2, 2, 0. There we go. And that's going to be J prime. H is over here at 4, 2. What's it going to turn to? -4, 2. This is going to be H prime. And finally, G was 2, 4. What's it going to turn to? -2, 4. There's G prime. And then I connect the dots. And does everybody see how those shapes are reflections of each other? Notice, what did this piece of the thing do? Went to the other side. What did this piece go to? That's the reflection. Yes. Yes. Yep. I might give you points only and ask you to reflect it. You might have to draw the picture yourself. Whatever you need to do. Okay?